My friends, sightseeing around again, and now let's learn about the modern physics, but I should not say it's modern physics. I should say it's photoelectric effect, because in this session we are going to discuss the photoelectric effect. And what do I say about modern physics? It's the most weighted chapter of the physics. The chapter having the most weightage, that is the modern physics, in any exam, any multiple choice exam you can ever guess. So let's get on with the photoelectric effect, not wasting your time. What is work function? Work function, as you can see written, I'll just read it for you. The minimum amount of energy necessary to free an electron against an attractive forces. That is, if this is metal, then what would be the work function, or what would be the energy to release an electron from this hold of the metal? That is its attractive force and nothing else. And we know what is the work function, I'm sorry. Work function is h times nu naught, where nu naught is the, which is a mu naught, because where mu naught is the threshold frequency. What is threshold frequency? Threshold frequency is minimum frequency for the photoelectric effect. Those who don't know what the hell is photoelectric effect, let me explain you shortly. Now suppose we have a right plate here, alright, and we are just applying a high intensity of light. It is light having the energy h nu, that is hc by lambda. Lambda is the wavelength, h is the Planck's constant, c is the speed of light. Then electrons are ejected. These are the electrons ejected. The electrons are ejected from the metal if we just make it incident from some photon. And nu naught is the minimum frequency for this thing to happen. Verify is h nu, the threshold wavelength. Simple maximum wavelength. Yeah, wavelength is inversely proportional, so we need maximum thing. So maximum wavelength for which the photoelectric effect is possible, where lambda naught equals to hc by phi. We know hc by lambda is phi. So lambda naught equals to hc by phi, where lambda naught is 12,400 electrovolts minus angstrom, that is 10 power 10 upon phi. Now what does the observation says? That is, number of photoelectrons emitted per second is proportional to the intensity. That is, number of photons emitted per unit second per second is directly proportional to the intensity. And second thing, maximum velocity of the electrons emerging depends on the frequency. The velocity of the electrons, that is, I will say here, velocity of electrons is directly proportional to the frequency, that is c by lambda. Third thing, photoelectrons emission is instantaneous. All knows that. According to Einstein, if W naught equals to work function, then h nu, that is hc by lambda, is equals to W naught plus half mv square, that is h nu minus phi equals to half mv square. Simple. Kinetic energy. Now kinetic energy of photons is hc times 1 upon lambda minus 1 upon lambda naught. Well, lambda naught is the threshold frequency. That is nothing but the kinetic energy. Simply expand this whole thing and you can get nothing. Stopping potential, the value of potential with which just stops the electron's maximum kinetic energy from reaching the anode. The value of potential which just stops the electrons of maximum kinetic energy from reaching the anode. I hope you understood what I want to say. Stopping potential, that is Vs, this is Vs, equals to h nu, that is hc by lambda minus phi upon E, where E is 1.6 into 10 power minus 19. So we know that, or we can say that EV, that is electrovolts, that is electrovoltage stopping potential, equals to half of mv square. So we can say also Vs is equals to hc by lambda minus phi upon E. Since we know hc by lambda minus phi is something which is half mv square, so half mv square equals to EVS. Now let's get down to our next page. What does this fucking says? Photoelectric current is proportional to the intensity. Yeah, number of electrons was proportional. Now photoelectric current, that is photoelectric current, that is I, is proportional to capital I, which is intensity. All knows that. Stopping potential is directly proportional to the frequency and does not change with intensity. Yeah, stopping potential never changes with intensity. As however we increase the light, its stopping potential is same, because it depends on that frequency, not that intensity, since intensity is not related to frequency. Now some graphs, some fucking graphs again. Photoelectric current versus potential difference. This is potential difference, this is the photoelectric current. At the saturation current, the potential difference becomes constant and it increases exponentially, as you can see. Now kinetic energy versus the voltage, and we can just obtain some of the graphs at the different voltages, that is V1 and V2, where the slope is nothing but the Planck's constant. Now what is intensity? Intensity is the amount of energy incident per unit area. Intensity is the amount of energy incident per unit area, where unit is joules per second per meter square. Or intensity is n times hc by lambda, where n times h mu, where mu is the frequency. And intensity of light at r distance from point source having power p is I equals to p upon 4 pi r square, where p is the power of that point source. So intensity is p upon area, since 4 pi r square is the area for the sphere or shell. So intensity is p upon area. Now let's get down to our next part, that is nothing but matter waves. De Broglie, yeah, one of the most important parts of physics. Energy of photons E equals to hc by lambda. Momentum of photons, we can say this is a very useful formula. P equals to E by C, the momentum of photon, the energy of photons divided by the speed of light, which is equal to h by lambda. Yes, however lambda is h by p, of course. Just equate this whole fucking thing. All moving particles like electrons, protons, where is E, come on, like electrons, protons and alpha particles etc. behaves like waves. The above wavelength is de Broglie wavelength, the lambda, which is h upon p, that is the Planck's constant upon momentum, is nothing but the de Broglie wavelength. Some formulas. For photon, lambda is equals to hc by E, that is h by p, since by above. For particles, lambda equals to h upon p, that is h upon under root of 2m into E, where E is the kinetic energy. We can say for photons, why did I write this like that, come on. For photons, E equals to hc by lambda. For particles, E equals to half mv square. For particles, P equals to 2 times E by V. Nothing for photons, we know what is photons, come on. Now for an electron, de Broglie wavelength is lambda, which is under root of 150. I don't think it's a constant, under root of 150 upon V, that is volts. And for any Gauss molecule where K is Boltzmann constant, lambda is equals to h upon under root of 2mkt. Nothing else. And quite a useless formula, never asked. And now let's talk about something which is more complicated, that is a Ritz combination. Suppose the electron is going from third to first orbit. That means if this is the third orbit, this is the second orbit, this is the first orbit, this is the nucleus. From third orbit to the first orbit. Now suppose the electron is going from the third orbit to the first orbit. It may first travel from n equals to 3 to n equals to 2, then n equals to 2 to n equals to 1. That means we have one probability that electron is going from 3 to 2 and then from 2 to 1. If total frequency from third to first is Vi, then hc by lambda from 3 to 1 equals to energy at third minus energy at first, simple physics, right? Or h into V32 is, now what does this thing 3 1, that means it jumped from directly 3 to 1, and here from 3 to 2 then 2 to 1, that is h into frequency of from 3 to 2 equals to h times frequency of 3 minus h times frequency of 2, where V31 equals to V32 plus V21. Yes, V31 equals to V32 plus V21. Now let's do it quickly, come on. Rutherford's nuclear atom. For nucleus and electron, centripetal force equals to mv square by r, k, q and q2 upon r square, simple force. Total energy equals to kinetic energy plus potential energy equals to minus of k z e square upon 2r. Very, very important. K z e square upon 2r. Bohr's atomic model. First postulate mv square by r is equals to 1 upon 4 pi epsilon naught z e by r, where e is 1.6 into 10 power minus 19 coulombs upon r square. Second postulate, which is I omega. I is the moment of inertia. I'll just explain it in the part of rotational motion. I omega equals to mvr equals to nh upon 2 pi. And as angular momentum and Planck's constant have same dimensions, angular momentum and Planck's constant have same dimensions, I'm sorry. As long as electron revolves around these orbits, they they neither lose nor gain energy. These orbitals are called as stationary orbits. Yes, of course. And what the third postulate says is when electron jumps from higher energy to lower energy level, then E2 minus E1 equals to hc by lambda. Oh my goodness. E equals to hcr into 1 upon n1 square minus 1 upon n2 square, where r is the number of orbits. Now Lyman-Bolmer Paschen bracket 1. Lyman series 1 upon lambda equals to r into 1 minus 1 upon n square, when n can be any integer, any other orbit we can say. Bolmer series 1 upon 4 minus 1 upon n square into r, n can be anything which is from 3, 4, 5. It's 2, 3, 4, it's 3, 4, 5, it's 4, 5, 6 to infinity, it's 5, 6, 7 to infinity, like that it goes on. So Paschen series 1 upon 3 square minus 1 upon n square, and is 4, 5, 6, 7 and all that. Bracket series 1 upon 4 square minus 1 upon n square, where r is Rydberg's constant 1.097 into 10 power 7 per meter. We have completed right now, my friends. I hope we should wind up right now. The video is being quite long. In the next part, I would explain you about the X-rays. So happy sciencing. Hope you learned something, and if you learned, then please like that video and subscribe, and please tell me what was wrong or how did I teach in the comment box. I would really feel blessed by your comments. And so long, happy sciencing.